what is infrastructure as code, or abbreviated as IAC. So we will look at what this is, why you might want to use it. Let's say as opposed to doing things manually or through makeshift scripting. And we will walk through an example where we create a very simple object through infrastructure as code. And we will build on this in future lessons. So let us say you're using AWS and you want to create an S3 bucket. If you're just creating a one-off S3 bucket, you can go to the AWS console and create the bucket through the console. But if you want to create many buckets or if you want to automate it so that you don't want to go to the console and rely on manual work, you can script it either through the AWS API or using the CLI and write a one-off script that does it. But if you want to do it far more systematic and take full advantages of infrastructure as code, you could use one of the infrastructure as code languages like Terraform or Pulumi or CloudFormation/CDK and write it through the infrastructure as code approach. It will give you a lot of advantages that we will look at as part of this list. So which IAC should you use? There are 4 common IAC modules. One is Terraform, the other is Pulumi, the third is CloudFormation, and the fourth is CDK. Terraform is the most robust, stable, and the oldest of all the IAC platforms. It uses YAML to specify your infrastructure as code specification. Pulumi is relatively new, but it is far more powerful than Terraform because it allows you to mix the infrastructure as code patterns along with the power of a full-fledged programming language. At the time of this writing, Pulumi supports Python, Golang, and TypeScript. In this lesson or in this series of lessons, we will use the 3 languages interchangeably, focusing more on Python and Golang, but we will also use TypeScript. For this particular video, we will use Python as an example. CloudFormation is AWS specific, so it is similar to Terraform in that it uses YAML for the specification, though the specification language itself is different between Terraform and CloudFormation. So you use CloudFormation to provision AWS resources exclusively. CDK is kind of a subset of CloudFormation in that you use a full-fledged programming language like Python or TypeScript to specify how you want to provision AWS resources. But in the background, CDK is translated into CloudFormation. We will not be focusing on CloudFormation and CDK in this series of lessons because we don't want to restrict our infrastructure as code to only AWS because Terraform and Pulumi are quite flexible that you can provision resources into multiple clouds like AWS, Google, Compute Platform, Cloudflare, DigitalOcean, so on and so forth. So we will this series of modules will focus specifically on Pulumi. But if you want to move into infrastructure as code, it is advisable for you to stick to a more generic platform like Terraform or Pulumi, unless your organization mandates that you need to use CloudFormation or CDK. So why does this video series focus on Pulumi and not Terraform? For one, Pulumi is free. Terraform is also free, so there's not a point against Terraform. Unless you use Pulumi to provision thousands and thousands of resources across several stacks, you can continue to use it for free. You can use a powerful programming language instead of YAML. YAML is quite restrictive in that you have to stick to certain patterns, but a programming language is not dependent on all these. So you can mix it with your existing code base, call external APIs, and use that as an interoperable module with IAC. It is limited only to your requirements and imagination. So like we saw in the previous slide, Pulumi supports Golang, Python, and TypeScript as of this writing. They come with a very robust type system combined with a very strong IDE. It is a joy to write programs for Pulumi. Pulumi Cloud is a state management tool that Pulumi gives you for free. Again, free asterisk if you don't provision thousands of resources. So by default, Pulumi can store your infrastructure state into the Pulumi cloud. And logging into Pulumi cloud, you will also get UI for free, which you can use to monitor your infrastructure operations. So this diagram shows the core concepts of Pulumi. A lot of these concepts are transferable to other infrastructure as code platforms, but we are focusing on Pulumi here specifically. So what you have in the orange box is the Pulumi engine. This is the core code base of Pulumi. Now, infrastructure as code is the code that you write to provision whatever cloud resources that you want to provision. Let's say AWS or Google Cloud Platform. Now, a cloud provider is a set of APIs that the IAC can use to provision resources for a particular cloud, let's say AWS. Certain cloud providers are provided by Pulumi natively because they are very common and popular. For example, Pulumi provides an AWS cloud provider as part of the code base itself, but certain third-party providers can provide their own code base to provision cloud for their cloud as long as they subscribe to the core Pulumi concepts. For example, Cloudflare provides a Cloudflare provider which you can provision resources in Cloudflare. Now, where IAC becomes very powerful is when you mix it with the concept of stacks. Now, if you consider IAC as a blueprint for whatever that you want to build, a stack is like the building. So that you can use the same blueprint and construct multiple buildings with a blueprint. Now, let us say you have 5 customers, and each of those 5 customers have their own cloud objects, right? So the same IAC will run across 5 stacks and provide 5 copies of or 5 sets of these cloud objects with the same code base. And they can run in parallel when you combine it with the CI/CD tool. You can also augment it with feature flags such that if one customer does not need a particular object because of a feature that you don't provide as part of your SaaS application, then you omit that object as part of your code base and make it configurable. So five customers could have almost the same thing, but not have certain objects or have some other objects as part of the stack configuration. Also, the stack is a replica of your infrastructure as code blueprint. Now, how does Pulumi Cloud fit into all this? Pulumi Cloud acts as both a state manager and as a UI for you to visualize the resources of a stack or any live operations that are happening. In this lesson, we will be provisioning a random password generator object with Pulumi. By itself, it is useless, but you could mix and match it with other objects, which we will be doing in future lessons, and it becomes quite powerful. This will not cost you any money because we are not provisioning anything on the cloud as yet. But in future lessons, you would be provisioning certain things, like let's say a secret manager object or an S3 bucket, and that would cost you money for the duration you have the objects provision unless you remember to tear them down. I will recommend you to do that. This particular lesson, we will use Python to do the random password generator. In future lessons, we will also switch across the Golang or TypeScript. I will not be teaching you the languages themselves, so I hope and assume that you have some basic programming knowledge, but you should be able to follow along the lesson even otherwise. I will be using PyCharm for the IDE. It should not make a difference even if you don't use PyCharm. You could use other IDEs like VS Code or anything else that you're comfortable with. PyCharm itself has a community edition, which is free of cost, so you could use that, or you could stick with VS Code, or if you're paying for any other IDE, you can use that as well. Now, to start following along, you need a Pulumi account. If you go to app.pulumi.com, you can set up an account here. It is free of cost. You need this Pulumi account to be able to use Pulumi Cloud and provision objects and view your stack state and stack objects and everything. If you are following along, going forward, I assume that you've already set up your Pulumi account and you have the IDE set up to start coding. In this lesson, we will be provisioning a random password generator object with Pulumi. By itself, it is useless, but you could mix and match it with other objects, which we will be doing in future lessons, and it becomes quite powerful. This will not cost you any money because we are not provisioning anything on the cloud as yet. But in future lessons, you would be provisioning certain things, like let's say a secret manager object or an S3 bucket, and that would cost you money for the duration you have the objects provision, unless you remember to tear them down. I will recommend you to do that. This particular lesson, we will use Python to do the random password generator. In future lessons, we will also switch across the Golang or TypeScript. I will not be teaching you the languages themselves, so I hope and assume that you have some basic programming knowledge, but you should be able to follow along the lesson even otherwise. I will be using PyCharm for the IDE. It should not make a difference even if you don't use PyCharm. You could use other IDEs like the VS Code or anything else that you're comfortable with. PyCharm itself has a community edition which is free of cost, so you could use that, or you could stick with VS Code, or if you're paying for any other IDE, you can use that as well. Now, to start following along, you need a Pulumi account. If you go to app.pulumi.com, you can set up an account here. It is free of cost. You need this Pulumi account to be able to use Pulumi Cloud and provision objects and view your stack state and stack objects and everything. If you are following along, going forward, I assume that you've already set up your Pulumi account and you have the IDE set up to start coding. The next thing you will need to do is you will need to install Pulumi CLI on your local machine to use Pulumi on the terminal. You will almost always, at least in the initial parts of learning and using Pulumi, you will almost always use it locally. And later, when you want to automate stuff, you will go to CI/CD system. So this particular URL, pulumi.com/install, has instructions on how to install Pulumi CLI on most of the major operating systems. So you can follow this. I will leave a link for the URL in the description. You can follow this and install Pulumi. So I will also assume that you have done this before you're continuing with the lesson. So when you log into Pulumi, you will be greeted to a screen similar to this. As you can imagine, it is quite empty. No projects or stacks. We will be creating that as part of this lesson for the random password generator. But before you do that, click on the top right and create a personal access token. This personal access token is needed for you to connect your Pulumi CLI to the Pulumi cloud. It is confidential, so you have to take care not to expose it or treat it like a secret. The expression is up to you, but if you tend to forget that you have a token, it is good to set an expiration date so that it auto deactivates after this particular time. But I will set it to no expiration. And this token is what you are seeing here. So we will use this to authenticate the CLI with the cloud. So if you have installed Pulumi successfully, typing Pulumi version should give you the version number, which shows that Pulumi has been installed properly. The next thing is you can use the CLI to log in to Pulumi Cloud. Type Pulumi login and type in the access code that you created from the previous step. And you can see that Pulumi logged in. So we will provision a new Pulumi project now. I will call it Pulumi password. Go into the folder and type in Pulumi new. So it will give you two options to either create a project from a template or use the new AI feature to create a project. But we will start with a template and we will pick a simple AWS Python project. Like we mentioned earlier, we will not provision any AWS resources as part of this lesson, but we can use this template at this time. So I will just call it password, leave the description as it is. And like we saw in the earlier graphic, each project is in the context of a stack. So I will just call this the main stack. And we will use the pip tool chain to install the dependencies and leave the AWS region as US H1, even though we will not be provisioning anything. Pulumi will now create a virtual environment inside which it will install all the dependencies. Okay, so now we have a project along with a set of initial setup files that Pulumi has created. Before we look into the code itself, there are a few things that we can look at. So this pulumi.main.yaml is your primary stack configuration because we call the stack name as main. In case we have additional stacks, each of those stacks will have a YAML file. Let's say the secondary stack is called backup. You will have a Pulumi backup YAML, for example. And Pulumi YAML is the primary configuration for the entire project itself. So it tells that the project name is Python, the project name is password, the runtime is Python, and it also has additional metadata on what the tool chain is being used and the virtual environment is called V. Now, at this point already, if you go to the Pulumi UI and you look at stacks, you see that you have your password project along with the main stack. The main stack will be empty, however, because the stack, we haven't done anything with the stack at this point, and the updates will also be empty. We will look at what updates mean a little down the line. Now we have the virtual environment. If we activate it and do quick freeze local to see what packages we have that Pulumi has installed. The primary packages are the Pulumi, which has the code for the Pulumi engine itself. Pulumi AWS is because it's an AWS project. The others are dependent projects that the Pulumi and Pulumi AWS packages need. We will install one more package called Pulumi Random. This is the random password generator. So like I already mentioned, uh, we will not be provisioning AWS resources, but we will generate a random password using our code. So we have installed the random project here. I already had it in my cache, so pip just installed it from there. So if you do pip freeze local once more, you see that Pulumi random has also been installed. So at this point, we can start looking at the code. We can look at the code generated by Pulumi. It is pretty straightforward. It imports the Pulumi engine, and from the AWS provisioner, it imports the S3 bucket provisioner, and it actually creates the S3 bucket and exports the bucket name. Now, inside the bucket, there is a logical name being given here. It identifies the Pulumi resource inside the stack, but on AWS, this name also forms the base for the target S3 bucket. And exporting is a way for you to introspect the value of the bucket name without the code in the stack context. We will look at what this means a little bit later. But like I mentioned earlier, we will not be provisioning any AWS resources on this lesson. We will clean all this up and we will provision the random password generator. One thing to tell you here is uh, the IDE will be helpful in cases where if you set this up properly, you can go and introspect the Pulumi code. So because um, infrastructure as code always involves provisioning a lot of resources across a lot of provisioners, you might need to introspect the base code frequently for you to identify which arguments to provide and how to set up the resource properly. So we will clean up the AWS stuff and we will use the Pulumi random um, module and import these two classes. And so we will provision a new random password. We will call it my password. And inside random password arguments, you can see that the IDE is giving us the introspection options. Not all of these are mandatory. So we will stick with two main properties. One is the length, the other is keepers. Now, now, if you can infer, this looks very similar to how the S3 bucket was provisioned. In general, resources uh, being provisioned through IAC and Pulumi in specific follow the same template. You assign the provisioning arguments to a variable, and then downstream you use the variable as either to export the result of some specific attribute, or you use this as seed to another resource, which is a more powerful pattern, which we will look later during the lessons. But for now, what we have done is we have provisioned a random password. We have given a logical name called my password, and we have provisioned the arguments. Length should be self-explanatory. We want a password of length 32. Now the keepers is a dictionary which is useful in case we want to rotate the password at a later point. So here I'm calling it seed one. Um, I will show what happens when we change the feed a little bit later. But for now, we have enough in the code for us to actually run the Pulumi update and see how Pulumi behaves. So I have the code that we created originally open on the right. So we can try running the Pulumi stack update. So you do that by doing Pulumi up. Now what Pulumi does is it does a preview first. What it means is that it goes through the code, identifies what objects need to be provisioned, makes directed as cyclic graph internally, and tells you what it is going to do. So it's telling you that it is going to create a random index password called my password, which is what you gave as a logical name, and it is going to create the resource. So if you go deeper into the details, it is exactly going to tell you what it is going to do. And this URN is a full-fledged universal resource name in the context of the stack. It will always be unique inside the stack for across all resources for that stack. And you can see that the properties for the object are going to be what we mentioned for keepers, and it's going to be length 32. It will also provide an output called password value, which is exactly what we mentioned here on the right. And this output is unknown at this point because Pulumi is yet to create it. Now, what you are seeing on screen is called review. Basically, it is an opportunity for you to inspect if everything that Pulumi is doing is acceptable for you and for you to confirm before proceeding with the update. This is important, at least in the initial stages, because more often than not, you'll be provisioning cloud resources which cost money. And in case there is a production context, you might want to double check everything before you actually deploy it. But on a CI/CD context, this pause for confirmation will not work because there is nobody to give the approval. So in CI/CD context, Pulumi has options where you can skip this previous step and proceed directly with the update. So right now we want to proceed. So we will ask Pulumi to proceed. So you can see that the update is complete. Pulumi has provisioned the one process we've asked it to provision, and the output is a secret because Pulumi recognizes that we are generating a random password and it is not showing the output of the password value so that it is obfuscated. Now, if you want to look at the output of the stack that we just provisioned, we run Pulumi stack output. So it tells you that the password value on the right, which you see, is the same as the export identifier, and the value is a secret because it's a password. But if you want to force Pulumi to show the password value, so you can see that this is the password that Pulumi has generated. Like I mentioned, on its own, this particular object might not look very useful, but it is useful if you want to see downstream objects. Like let's say you create an RDS instance and seed it with the password value. These options are quite useful. In the future lessons, we will, at least in the next couple of lessons, we will build on what we did here. We will use this my password object. We will update the seeding and show how the password value changes. And we will also use it as a downstream dependency on another object and see how Pulumi propagates these changes. Now, if you go to the Pulumi cloud, whatever we did on the terminal will be reflected here because the CLI syncs operations to the cloud. So if you go to resources, you see that there are three resources here. The the stack and the uh, providers used are always present as part of the listing. But the random index password is what we provisioned here, and you can see that the attributes that we specified are being reflected here. All the other attributes that are also available in case you wanted to provision them with different values, they are all present here with the default values. One last thing is on the resources, you can also do a graph view. In case there are multiple resources, you will see a directed acyclic graph of how the dependency chain flows here. So with that, we will conclude this particular lesson. Now, if you want to look at the output of the stack that we just provisioned, we run Pulumi stack output. So it tells you that the password value on the right, which you see, is the same as the export identifier, and the value is a secret because it's a password. But if you want to force Pulumi to show the password value, so you can see that this is the password that Pulumi has generated. Like I mentioned, on its own, this particular object might not look very useful, but it is useful if you want to see downstream objects. Like let's say you create an RDS instance and see it with the password value. These options are quite useful. In the future lessons, we will, at least in the next couple of lessons, we will build on what we did here. We will use this my password object. We will update the seeding and show how the password value changes. And we will also use it as a downstream dependency on another object and see how Pulumi propagates these changes. Now, if you go to the Pulumi cloud, whatever we did on the terminal will be reflected here because the CLI syncs operations to the cloud. So if you go to resources, you see that there are three resources here. The stack and the uh, providers used are always present as part of the listing. But the random index password is what we provisioned here, and you can see that the attributes that we specified are being reflected here. All the other attributes that are also available in case you wanted to provision them with different values, they are all present here with the default values. One last thing is on the resources, you can also do a graph view. In case there are multiple resources, you will see a directed acyclic graph of how the dependency chain flows here. So with that, we will conclude this particular lesson. So with that, we will conclude this chapter. Even though the code that you see on the right looks very small, we've covered a lot of ground here. We set up our Pulumi account. We also installed the Pulumi CLI. We created a new stack called main. We initiated a Pulumi Python template based on Python AWS, though we did not provision any AWS resources here. Then we added the code, provision a random password called my password. We previewed the stack outputs that Pulumi showed us what it is going to do. And we performed the Pulumi update, where the actual my uh, password was generated. We introspected the stack output, where we saw how we can see the value of the password that Pulumi provisioned. And we verified this result on Pulumi Cloud. So we will conclude here. We will build on this on the next lesson. I will leave a link to the code on the GitHub repo, which you can use for reference in the future. Thank you and see you later.